Welcome to this explainer. We're jumping right in today because we are diving into the absolute bedrock of network security, access control lists, or ACLs. If you want to understand how networks actually protect themselves right at the core, you are in the exact right place.
Now, I want you to think about something for just a second. Who actually guards the doors to your network? I mean, with the sheer chaos of thousands of data packets flying around every single second, how does a router actually know who's allowed in and who gets kicked to the curb? You absolutely need a frontline defense.
Well, that frontline defense is the access control list. Basically, an ACL is a set of rules used by routers and switches to control your network traffic. The keywords you really need to lock in here are permit and deny. When packets enter or leave a network device, the ACL acts as a filter. It evaluates that traffic and decides its fate based on those strict rules. It's exactly like a strict security guard at a physical building entrance. Think about a corporate office. Regular employees can walk into the lobby, right? But only the IT team is allowed into the server room. The router's ACL is that guard with a clipboard inspecting the IDs of incoming visitors, or in our case, data packets, and deciding exactly who gets to enter and who doesn't.
Okay, let's dive into this. Here's our roadmap for today. 1. The Network Security Guard. 2. How ACL processing works. 3. Standard versus extended ACLs. 4. Inbound, outbound, and wildcards. And finally, 5. ACLs versus firewalls.
Let's kick things off with Section 1, the Network Security Guard.
So why are these digital bouncers so absolutely crucial for protecting our infrastructure? Well, ACLs serve a few massive purposes. Obviously, they control network traffic and improve overall security by restricting access to sensitive resources. But actually, it's not just about stopping bad actors or separating departments, it's also about pure efficiency. By filtering out unwanted traffic early on, ACLs literally reduce network congestion. They're the primary tool administrators use to take a company's written security policies and actually enforce them in the real world.
Moving right along to Section 2, how ACL processing works.
I want you to imagine following a single tiny data packet on its journey right up to a router's interface. The router puts that packet through a very rigid gauntlet. First, there's top-to-bottom processing. The router checks the packet against rule number 1. No match? Okay, it goes to rule 2, and so on, strictly chronologically. Second, and this is key, first match wins. As soon as a packet matches a rule, whether that rule says permit or deny, processing stops immediately. The rest of the list is completely ignored. And finally, the third step
Is the implicit deny. Think of this as a hidden trapdoor. Every single ACL automatically ends with an invisible deny all rule. Even if you didn't write it yourself, it is sitting there at the end of every checkpoint. So, if your packet goes through the whole list and doesn't explicitly match a single rule, the trapdoor opens and the packet is automatically dropped. It's that simple. If you aren't on the list, you don't get in.
When we're building these rules, we rely on a few specific keywords. Permit allows the traffic, deny blocks it, pretty straightforward. But we also use any, which is a wildcard representing literally all addresses everywhere. On the flip side, we have host with zeros in on one single specific device, just one exact IP address.
Okay, let's jump into Section 3, Standard versus Extended ACLs.
There are two main categories of ACLs we need to talk about. Standard ACLs are basically your quick VIP list at the door. They filter traffic based only on the source IP address. They honestly don't care where you're going, just where you came from. It's simpler and it's much faster. Extended ACLs, however, well, they're a deep background check. They filter by source, sure, but also by destination IP, the specific protocol you're using, and even the TCP or UDP ports. They check who you are, where you're going, and exactly what you're carrying. Now, in traditional Cisco environments, the router knows what kind of ACL you're building purely based on the number you assign it. Standard ACLs use numbers 1 through 99, and then there's an expanded range of 1300 to 1999. Extended ACLs use 100 through 199 and 2000 to 2699. If you're an IT student or working toward a cert, you're definitely going to want to lock these specific ranges into your memory.
But let's be honest, relying entirely on numbers can get a little tedious. Actually, it can get really confusing. That's why we also have named ACLs. Instead of trying to remember what ACL 150 is supposed to do 6 months down the line, you can literally just name it sales_access. It makes your configurations infinitely more readable and a whole lot easier to manage.
And because those extended ACLs look at specific protocols and ports, you can get incredibly granular. You can write a rule that essentially says, allow this specific IP to access web traffic on port 80 and 443, but deny them from trying to transfer files over FTP on port 21, or block them from logging into the router via SSH on port 22. It is the ultimate tool for detailed traffic control.
All right, Section 4. Inbound, outbound, and wildcards.
Once you've actually crafted these rules, you have to apply them to a router interface, and the direction you choose matters immensely. An inbound ACL filters packets the moment they enter an interface, before the router even wastes time figuring out where to route them. Blocking early saves incredible amounts of router resources. An outbound ACL, on the other hand, filters packets right as they are leaving an interface, after the routing decision has been made. This controls exactly what exits a given network.
Now, to specify networks in these rules, we use something called a wildcard mask. This replaces a standard subnet mask, and I know, it looks a bit backward at first. In a wildcard mask, a 0 means the router must match that number exactly, and a 1 means ignore. So your typical subnet mask of 255.255.255.0 becomes a wildcard mask of 0.0.0.255. It's essentially telling the router to strictly match the first 3 octets but completely ignore the last one.
Because of how these rules function, there are a few golden rules, best practices, to avoid accidentally blocking legitimate traffic. You should place standard ACLs as near to the destination as possible, because their lack of specificity might block things unnecessarily if you place them too early. Conversely, place extended ACLs near the source to stop unwanted traffic right out of the gate. Always document your rules clearly, test carefully, and follow the principle of least privilege. Only allow the traffic that is absolutely required.
Finally, Section 5. ACLs versus firewalls.
A question that comes up all the time is, if I have an ACL, do I even need a firewall? Well, yes. While ACLs provide basic filtering directly on the router and process incredibly fast, firewalls are dedicated security devices providing deep packet inspection. They look deep inside the packet, not just at the headers.
So the takeaway here is that they aren't competing at all. They're complementary layers. ACLs act as your indispensable first line of defense. They're a lightweight, ultra-fast, fundamental security layer that drops the obvious junk traffic right at the router. This provides vital traffic control before your heavy, expensive firewalls take over to do the complex, deep inspection.
And that wraps up our explainer. But before we go, I want to leave you with a thought. Think about the networks you use or the resources you manage every single day. If your network doors were tested today, would your rules be tight enough? Would your implicit deny keep the intruders out? It is a critical question to ask yourself as you build and secure your own infrastructure. Thank you so much for focusing and learning with me today. Keep asking those tough questions and stay curious.